Okay, so on the back and forth method, it's really similar to the tabulation, but it's kind of not going the extra step of writing down numbers and changing extra numbers. You're just writing down a few numbers. I do have a recommendation. When you have polyatomic ion groups, it's hard sometimes to see them as like one thing. So this is one NO3 group. So I'm putting a square around it just to kind of emphasize that that's a group that's NO3. Notice there's two on that side and one on the other side. I'm also going to go ahead and do this over here with the Mg and right here with this one. As I'll note, this is the same thing as water, but when you're balancing and it's a double displacement like this where you have a positive, negative, it can be much easier to do the balancing if you rewrite water like this and then write it as H2O. It's not technically correct to put HOH, but man, it really helps with the balancing. So we're going to go back up to this first one. Remember, we're still looking for like a 2 somewhere at the bottom. Right there is where he is. So the first thing we're going to try to balance is the NO3 group. So I'm going over to this side over here, and I'm going to put a 2 in the front here. Now, I'm not tabulating it. I know I've already fixed the NO3 group. But so the NO3s are good because I just fixed them. But I know that the 2 also is going to influence the other thing that's attached. So it influences the Ag. So now I need to find the Ag over here, and I got to put a 2 in front of that Ag. And then my last little check, just double check that my zincs are good. They're good. So if you kind of followed what I was doing, I basically just fixed things one at a time, and I just make sure I didn't skip anything when I was doing it. Let me show this next one. So again, I'm going to look for something that has like a little 2 on it. So the 2. So remember, I've got the square around the OH. So right now what I'm fixing is this OH group on this side. This OH group is now 2. Now I've influenced this H, the solo H. So I'm going to go over to the left side. Here's an H, and it's a solo H. And so I'm going to put a 2 in front of him. So my H's are good. I don't have to tabulate it. I'm all good to go on my H's and my OH's. Now I need to fix my fluorine, because that influenced my fluorine. So I go over, oh look, my fluorine is already fixed. Then check on the last element, the Mg, and they are already fixed. So the back and forth method just kind of takes out the tabulation, and you just keep fixing something that's ionically bonded to something else. Like you just keep fixing the opposite charge every time you go back and forth. Every time you influence one thing, you have to remember you've influenced the other. And the back and forth method works best with these, which are single displacement, and also works really well with double displacements. It makes it a lot faster. Combustions can be hard to work with the back and forth, but that's only because you have oxygens on the right for a CO2 and a water, so the oxygen's in 2 places. You can still work it kind of back and forth, but at the end you will always have to pause and add those 2 oxygen sets together before you finish the balancing. And sometimes the decomposition works really well with back and forth, and sometimes it doesn't. It just depends on what kind of decomposition it is.